This is the first of the videos that I'm going to record to help you with the mock paper that we did recently. It was a 2013 paper, but you did it as a mock, and you did well in it. But when you help you revise, and also on those questions you found difficult, I thought I'd put together a quick video. Each question is going to be a separate video, so the overall thing is going to be quite long, but that means you can choose which one you want to look at. So this is question 1. We have a question that states, hopefully you can read it at the top there, that we have 3 horizontal forces acting at a single point. They have magnitudes 12, 14 and 5 newtons, and act along bearings 0, 0, 0 degrees, 0, 90 degrees and 270 degrees respectively. Find the magnitude and bearing of their resultant. So what we got is we got 3 forces. And when this is acting horizontally, what it means is they're acting within the same plane. So you can imagine looking down on a point P, or any point, and those 3 forces are acting within the same plane. You don't have to worry about resolving forces in 3 dimensions, which is totally beyond the scope of this course. So there's my point, and I've got 3 forces. The first one is 12 newtons, and it's acting on a bearing of 0, 0, 0 degrees. Now typically convention says that we put north as up the paper, but it's totally up to you which direction you put 0, 0, 0, as long as all the angles are correct relative to that. But I typically always put north up the paper because it makes it look the same as every other question that the examiner is going to mark. So there's no need to make their job harder than we have to. The next force is acting at a bearing of 90 degrees, or 0, 90 degrees, so that's east. And that force is 14 newtons. And this force here, acting up, is 12 newtons. And the last force is 270 degrees, which is west. So that's like that, and that's a force of 5 newtons. So as usual, and as I've asked you to do in every problem, you start with the diagram. You take that paragraph of words and you turn it into a diagram. Now quite a few of you didn't actually get all the marks on this question, and you'll see why you lost a few later on. Now I have to say though, when we set this mock, we didn't have the mark scheme, so when we marked it, we may have been more lenient on some areas or harsher on some areas, but so we've had to try and guess what the marks would have been given for. But this is a 5-mark question. Okay, right, so they are the 3 forces, and we've got to consider what the single resultant force, what direction it would be in, and its magnitude when you combine those 3 forces together. Now there are a number of ways of doing this. It's not an equilibrium, so I wouldn't want to draw a triangle. If it said it was an equilibrium, I would draw a triangle, but it's not. And I don't want to be working with a quadrilateral and trying to work out a missing side or an angle. We could resolve the forces horizontally and vertically, but again, I think the best way of doing this is to understand that the resultant force, force R, is going to equal to F1 plus F2 plus F3. Okay, and they're all vectors. So I'm going to say this is F1, this is F2, and this is F3. So if I combine my 3 forces together, I get the resultant force. Now, in order to combine those 3 forces together, the best way of doing that is to write those, well, I think the best way of doing those is in column vectors. You can use I and J unit vectors as well, but I much prefer column vectors. Okay, and we get a choice in our exam board of which ones we want to use. So there's my column vectors. Now I'm going to define my force in my x direction to be the horizontal, and the y force is, well, when I say horizontal, I mean to the right and up on the page. So I'm setting up my problem each stage. If I've introduced unit vectors, column vectors, I've also introduced my horizontal, my fx and my fy. So looking at the first force, F1, it's got no component along the x, and it's got 12 up. So there's the unit vector for that. F2 is going to be 14, 0. And F3 is going to be -5, 0. So now I can write that the resultant force Fr is equal to 0.12 plus 14.0 plus minus 5.0 which is 9.12. So now I know what the x and y component are of this resultant force, so I'm going to draw a quick diagram where it's going to go 9 to the right and 12 up. And that will give me my angle theta, and the length of that line will give me the magnitude of the resultant force. So let's work out the magnitude of the resultant force first, and that's going to be the square root of 12 squared plus 9 squared. Okay. So the magnitude of the resultant force is the square root of 225 or 15 newtons. Don't forget the units. Right, now we're going to work out theta there. So we know that tan theta is equal to opposite divided by the adjacent. So theta equals tan to the minus 1 of 12 over 9. Which is 53.1 degrees. Now, we were asked for the bearing. This is where quite a few of you made your mistake. So the bearing is always relative to north, which I've defined as up this direction on my paper. So I'm actually wanting this angle here, which is phi, not theta. So the bearing is going to be 90 minus 53.1 degrees. Now you could have got there directly if you used the triangle 12 up 9 across, but you can do it this way as well. So the bearing equals 90 minus that, which is 36.9 degrees. But again, it's a bearing, so what we're going to now put at the end bottom is the resultant force is equal to 15 newtons, and the bearing at a bearing of 036.9 degrees or 037 degrees, and put that in a box. So there's question 1. Quite a few of you forgot to give it as a 3-figure bearing, you just wrote down the angle. Remember, bearings are given with 3 figures. Back to GCSE. They gave them 3 figures in the question, so you should give yours in the answer. So there's my answer box there.